and we'll figure out where to make them officially available. The goal is to make them publicly available. But it's my first time doing it, so no promises. 50-50 shot. That works.
The one that take it.
Yeah. Yep, I got it.
Is it recording?
I just turned it on.
We'll see you in a minute.
Yeah, so open source is on the AWS.
All right, we'll see when I upload it how it looks.
We have like our own thing for
Like 20% as free already. I hope it's actually working.
but ultimately,
So there's going to be the end, and you see there's no audio.
and most of it, we have
I'll try and send just a little camera.
Yeah, that's a good idea. Think of that for next year, I think.
Hopefully next year we get that fixed up.
Yeah, that would be
a big change.
really awesome. I could hang a QR code. You can scan it and get the whole story.
There's something I wrote about.
Or a little QR code. You want your presentation?
I love learning.
$10.
Right, there we go. Monetizing.
Okay, we're gonna
Search engine.
ease into this here. All right, well, thank you for coming at 5 o'clock, which to me is like crazy. 5 o'clock on a Saturday, you should be somewhere else. This will be interesting for both of us because I'm breaking all the laws of demos and doing probably way too much at once. We're going to start out with a little bit of slideware. Won't be as vicarious and colorful as what Mr. Q did for us, but I want to set the stage because there's some ideas I need you to understand before I get into the actual meat of this. So first I'm going to tell you a little bit about myself. I have been using Solr since Solr 1.4. I have never used it as most people use it. I mean, most people are helping, companies like Amazon, have a search solution so people can, find products, buy things, e-commerce, or they're helping people in large enterprise, right? Try to find content in their enterprise. I seem to have fallen early on into an interesting niche, which is people have data and they're like, hey, we want more value from this, or there should be things in here we could learn from it, but we're not. Or as Eric talked about, the data is really, really messy, and that just stops us from answering some questions. And so, would it be possible to actually make this data act like they were highly structured? And that's what I got into in about 2010. And so before we had this lovely phrase, data scientist, people would ask me what I did, and I said, well, I make people's content more actionable. And that is everything from, where did it come from? What domain is it in? What's in it? Because most often when my clients give me data, even though they're confident, they say, this is what this is. I'm like, no, it's not. You're forgetting about some edge cases and use cases. So I am, data scientist is kind of a vague term, but I'm someone who has always been focused on this nature of making things more actionable and using Solr to do it. And so about 3 years ago at Buzzwords, I saw a couple of presentations that I really enjoyed, and I noticed that the lexicon that we have in the search community is not always aligned. Like, I saw 2 presentations, people talking about the exact same general thing using very different words, and they were back to back, and I felt like I was the only one who realized, like, you're talking about exactly the same thing, you're just looking at it and describing it from a totally different angle, and therefore people, didn't really make the connections they could have made. So that got me thinking, like, hey, could we do a better job of having a lexicon in search? And hey, couldn't we have a better way to share our whole experimentation with search? And that's what this talk is about. So, you gotta bear with me, we've got a little bit of context I'm going to try and set. But basically the agenda here is we're going to talk about 3 things. We're going to talk about a person, we're going to talk about a practice which is emerging, thank God, and then we're going to talk about the experiment itself, which is a tool that I'm going to show you. So the first thing we're talking about, the person in particular, is Thomas Edison. And I've always loved this probably misattributed quote from Thomas Edison. But apparently, at least when I first encountered it, he was asked, how have you managed to create so many great innovations? And supposedly he responded, really it's quite simple. It's a function of how many experiments I can do in a day. And if you look at his career, that is really not something he just believed, but he really took to heart. He actually created what was probably one of the first innovation factories that ever existed, literally focused on trying to accelerate how research is done and how new things can be brought out. And it was, interestingly enough, centered around teamwork and collaboration. It was designed, in the way he thought about it, to be flexible and yet at the same time to be very systematic, right? And even though this is we're talking about something that is over 100 years ago that someone was doing, it was the essence of what his productivity and his realization of value came from. I just wanted to set that as a stage because to me, history is repeating itself yet again when we look at this thing I'm talking about, which is exploratory data analysis, in that we today have gotten all excited about artificial intelligence, right? I'm trying to set some context here around when we talk about different terms, what are we really talking about? So artificial intelligence aims to have a system perform tasks that sort of are fitting in for what the human would do normally. But how does that relate to these other terms we're talking about, right? Because we have machine learning. Well, machine learning is something that is very much inside of the domain of artificial intelligence. But it itself has, as we know today, when we think about transformers, these large models, these LLMs, we have deep learning. But what is all that fitting inside of? That all fits inside of data science. If we did not approach understanding what the data is itself and how we can actually bring it to bear in a certain way, we would never have these models, right? It is both the combination of the algorithms and the data that make this possible. Now, one distinction that I would make is that there is a portion of AI, you may not have realized this, that is very much not part of data science, that is not part of machine learning, and that is not part of deep learning. And if you want to know exactly what that is, there's a great book that a professor from MIT who specializes in AI on it, and that is in the area of utilizing intelligence as opposed to mimicking intelligence. So the LLMs we have today are strictly mimicking intelligence. You may have heard of a paper that came out of Google, I think in 2021, it actually got somebody fired from Google, and it referred to the whole notion of models that we're dealing with now as really stochastic parrots. They're just parroting what they've seen, they're very large, so unlike your typical parrot that would say 5 or 10 things, they can say 5 or 10 billion things. But that's, again, part of the context I'm setting here. But when we talk about data science and the work that I've certainly been doing really in the last 15 years, I have always been given data and had to discover what the heck is it that I'm really dealing with. So I'm now going to explain to you how exploratory data science fits in the context of machine learning, fits in the context of actually creating models. Now I'm not really intending at all to talk about LLMs. I'm talking about all the other algorithms and models that are out there, and there are a lot of them, that are not these general application search tools that we're trying to use for RAG. And that's really where I focus, both in NLP and in quantitative analysis. But typically, this is sort of the classic client engagement situation as a consultant. Somebody's got a desired capability and a problem, right? Sometimes it's just that they want to fix a problem, or other times they want to just sort of move forward beyond their current capabilities. But there's 4 basic legs to machine learning. There's, of course, the problem and the desired capability they're trying to connect, but there's the problem space itself, which is typically a domain, and then there is a solution space, which certainly when we start to look at using data as a way to create a capability, we need to understand those algorithms. So these 4 things will come together, and in particular, if we're talking about data, what we're really talking about is using data to solve a high-dimensional problem using complex function approximators, right? I mean, we all took probably some level of algebra. We learned about functions and basic mathematical concepts to do with the application of a function. But here we're just talking about something that deals with something that is very complex and very large and maybe a little bit harder for us to penetrate mentally. So how do we go about this, right? On the top, I would argue one of the things that gets glossed over a bit, at least in projects that might find themselves not being successful, is you have to understand the domain, whatever domain that is. If you're in e-commerce and selling things, you have to understand what is going on with your customers and what people are doing. If you're in dealing with logistics and the movement of goods, or you're dealing with space research, you have to understand those domains to make sure that what you're actually doing with that content is going to have applicability to what you're actually trying to achieve. On the bottom side, on the solution space, you've got algorithms. And the unfortunate thing about the LLMs to me is that they have really sucked the oxygen out of the room, and there's really just a huge number of algorithms that can do many different things. A lot of them are maybe not even more contemporary deep learning models. They're statistical models, they're Bayesian models, they're ways that we can solve problems with algorithms. But we have to understand both sides of that before we're going to be able to connect between the problem and the desired capability. So what that typically means in a machine learning perspective, where we're going to rely on the data, is the data is our signal source. And that signal source, we need to make sure that it has got strength and fidelity. And so that means, in my job, I have to really understand data. The number of times that I have been given data and it is not what the client has stated it is, or has all kinds of issues and challenges that would have made it in its current state unusable, is almost 100%. Right? There's never been a time where somebody said, hey, I'm giving you X, it's perfect, it's clean, and that's exactly the case. But what this means then is we have to go through a series of steps to get from the raw data we start with to something that we can actually hand to an algorithm to make a model. And so this process is a very highly iterative process. It is a wandering through the jungle sort of experience, because you're very quickly going to discover, at least in my experience, that you could go in many different directions. You're trying to be efficient with your time. You're trying to make progress. You want your client to feel like, hey, we're getting somewhere, but you're encountering and discovering new unknowns as you go. And that causes you to loop back. But generally speaking, you go from understanding the basics of your data from a basic exploratory data analysis perspective through a process of filtering down to the signal that has the highest fidelity, correcting, shaping, and boosting that signal, as well as pulling out latent features that may have not been inside of that, original data, getting to an encoding, which from a machine learning perspective is actually huge, because encodings have to do with how well the algorithm is going to be able to pick up on the signal you're giving it. So just as we may look at something and say, aha, that looks obvious to me, well, guess what? That algorithm may not pick up on it. I'll give you a good example. Images, right? So if you're doing image recognition, anybody know how many different encodings there are for images, for color? I'm talking about dozens. And it turns out that some of those encodings are really good for solving some image problems and really suck at others. And so if you don't pay attention to the encoding you're using when you're sending it in, boy, you're going to be wondering, like, why am I hitting a glass ceiling? Why is this thing not doing any better, right? It's just like almost trying to talk to somebody when you're not talking their native language. You have to understand what signal you're getting, how you're shaping it, and then how you're encoding it so the model can understand. But ultimately, here's the other sort of funny thing, a little sort of hidden riddle about machine learning. The most effective things I've done for machine learning are not just about the final algorithm I run something through, but all the algorithms I apply to the data itself to further discover what it is, the features that are there, to expose them, to then make them as rich as possible. So one example I would love to talk about today, but I can't because I'm under an NDA, is I'm working with a client who has telemetry data. And the telemetry data, I can say, is really just about a single parameter. They've got a single parameter. And I'm like, what are you thinking I'm going to do with a single parameter? My background is in NLP. I've done all kinds of things like identity recognition, topic modeling, multi-label classification on text, all kinds of fun things in the NLP space. And when I got into this problem, I'm like, you have such little signal. But then what I realized is, when you have signal over an extended period of time, and you have a time dimension to it, all of a sudden there's an amazing cornucopia of potentially latent features that are in that signal. And so I've been working with that project for now about 6 months, and I have discovered, it's just blown my mind how much you can extrapolate, right? Because you start out pulling out one thing that leads to another thing, which leads to another thing, and before you know it, you're teasing out behavior. But in this context, we're trying to build up towards a model. The algorithms that we use they're not only relevant to the actual intersection of the domain that we're working with and the data that we're working with, but this whole process itself becomes very quickly one of not just get to something that you can verify and explain to get to efficacy, but it becomes this web of iteration, right? As you go forward, you will start to discover, I need to go backwards, right? And this is why I have loved using Apache Solr. So if you look at each step on here in a very large complex project that I've done, almost every step becomes almost like a collection or an index. I start out with an inventory. Somebody gave me a bunch of data. And then from there, I will go through and do exploratory data analysis, which really means I'm putting it into its first, most actionable form without me fully understanding it. And then as I start to understand it more, I will create a second index, which is a representation in a more enriched state, where I've pulled out more and more features. And you can keep chaining these forward, and as you're learning, this is just what we do as humans. As you learn about something, as you become an expert in the space, you have more sophisticated understandings of a domain because of the progressions of the observations that you have. And that's essentially the way I use technology. It is this fundamental tool that makes this whole chaining process possible, especially when I'm not dealing with 1,000 records. I'm dealing with maybe hundreds of thousands of records, if not, a billion records. And I have to tease out not just the signal, but I have to separate the wheat from the chaff. So, here's the experiment. How, when I mentioned Thomas Edison, how can we think about what would be making today's data scientist, today's researcher, more empowered and more accelerated in their journey to do this type of work? Just as he created an innovation factory for a lot of what was physical engineering in his day, how would we do that today? I would put forward the fundamentals that I have always looked for as I've progressed through this. They're things that cover many different dimensions, right? It's not just that I want an algorithmic tool. It's not just that I want visualization capability. It's not just that I want to be able to measure things. I need these things all to be together. In fact, if you look up the definition of data scientist on Wikipedia, I think that the definition is pretty darn good, because it says one of the unique things about a data science professional is that it's an interdisciplinary problem. You have to understand multiple different disciplines at the same time, right? Not just because I understand statistics, but I understand how I can visualize complex things related to statistics, right? And so as I've done this work, there has not been one tool out there I could go to. There's been things that are sort of close to it, but I went through and sort of came up with these questions after this conference in Berlin 3 years ago. And I was like, what if I tried to build this thing myself? There's a lot of tools that I've looked at that I like, but they don't all quite do the job. And I do need, I'll just mention one of the capabilities here, I do need a high-speed multi-dimensional data store, which is where I love Solr and Scene, because it allows me to pump a massive amount of data into something and then to analyze it. But I need that expressive query language. Some people I talk to, they're like, well, why don't you use a relational database? I'm like, a relational database is great, but it was originated for solving a different problem, which was actually data storage costs, right? My problem is how fast I can move data, how quickly I can iterate over it. And that I can do much faster, I find, with something that's based on Solr and Scene. But I also need extraction. I also need the ability to do on-the-fly transformation. And something else that really irked me for a long time is I need to do in multiple languages. I personally, my favorite language is Scala. Maybe, one day I'll learn Kotlin. But I realized that I have to jump into different languages to get different capabilities. So I also will code in Python. I'll also code in C. I'll also code in JavaScript. It's not because I love them. In fact, I can honestly say I really hate Python, but that's like saying I really hate duct tape, right? And I gotta say, duct tape is damn useful at times, right? And so that's what Python is. It is something and that's originally why it was created. There was a gentleman in Amsterdam. I've been to the research facility where he was working. It's like he had multiple C programs. You want to bring them together. Boom, I need a language to bring those things together. So this thing I'm about to show you, and again, I'm emphasizing the reason I went through this context is I didn't want to just show you this tool and be like, oh, here's a fun tool. I wanted you to understand the background of why I went after creating the thing you're about to see. And I will tell you the thing you're about to see is very much alpha. It's not beta or general release, but it's exploring these questions. Essentially, it's a mashup of Apache Solr with JavaScript for visualizations, because JavaScript today has, if you don't know this, the most powerful visualizations, far better than anything you're going to get out of Python, in my opinion. Data frames, not pandas, using polars. Polars is written in Rust. The gentleman who wrote it during COVID should be given a Nobel Prize. It's phenomenal. I love it. Uses arrow underneath. Got scripting, because I need multiple languages. I want to be able to jump to multiple languages. And this tool at the moment we support, roughly speaking, 5, and I hope to add a 6th and a 7th. And you need an editing experience. You need to be able to work with, because inevitably you're going to have aspects of code. And then finally, Jupyter Lab is something that I've used quite a bit, and when it went from Jupyter Notebook to Jupyter Lab, it was a big step forward. But personally, I felt like it could have gone further faster, and so I felt like I couldn't really use it. So without further ado, let's see if I can get to the really embarrassing moment where this doesn't work. So everything seems to be running. All right, so we're going to bring this thing up. The name for this is the Navigator. Let me get you oriented on what you're going to be looking at. Yeah, at least we're starting in the right place. Unlike,
Can you change the resolution, by the way? Or?
oh, is this just kind of small?
It's washed out.
Yeah. Sorry, I can adjust it. Just out of curiosity, if I
Could this light be turned?
the light, sorry, I don't have a dark screen mode. Yeah, you can kill it or
Does
dismiss
this-
it or. Oh, is that?
Did that do anything?
A little better.
I can jump it a little bit here. I apologize.
Most dangerous part of the demo.
Yeah, here.
Is-
Hold your breath. Here we go. Is that better?
We're doing another one?
Yeah,
Oh,
you do one more step.
I can try one more step.
I'm a little nervous unplugging these because of the project.
No, I don't.
No, no, no,
I think
no,
you're good.
no,
Yeah,
no.
we'll just.
Okay. Thanks.
Yeah.
That was the do not pass.
Progress, not perfection.
It's better. Thank you.
Okay. So let me try and get you oriented here. So if you've used Solr, Solr has an admin. It's in Solr. So you're basically calling an HTTP service inside the application itself. This is very much intended to be outside, right? This is kind of like an IDE. It's like, hey, I want to go to different environments. And so, yes, I can literally, jump around between different servers, right? Different clusters if I want to. At the moment, it supports Solr. Maybe if we have time at the end, I'll mention the fact that it actually also supports Vespa. But anyway, we won't get into that right now. But the basic idea is, if you think about the work we do, we have in our lexicon, just as developers or researchers or scientists of some sort, we have this notion of a cookbook. And we talk about recipes, we talk about notebooks. Why not make that a formalism, right? So Jupyter Lab and Colab have the notion of a notebook. I here am trying to make it intentionally a little bit more of formalism. So unlike Jupyter Lab, I'm putting a lot more potential and capability into the outline that you see on the left. So it's not just this thing that is summarizing what's there, it's actually something that is allowing me to navigate the document, to even determine what I'm running in the document, and to even, if I wish to move things around in the document. So it is very much a real part of the whole experience. The other thing that's very different if you know Jupyter Lab or Jupyter Notebook is that I very intentionally have put the response pane not in line with the code, which I personally always found very challenging. It's a right frame. So you see here, it's actually on your right. It's not like as the code executes, and if I have diagrams or output, the whole thing just sort of grows and becomes very hard to navigate. This thing is multi-perspective. So just to get a basic orientation, we're going to go ahead and run this.
Could you please maybe zoom in that way, I think, or the part that you want to highlight, maybe it will be more visible.
So you want me to zoom in again?
Ideally, or change the resolution, but yeah.
It's going to get dangerous here.
Okay.
Oh, that's
even better.
That's
That's good. Yeah.
All right, I apologize. I mean, because I do a lot of visual analytic work, most of the stuff I build is for high resolution screens. So every time I do it on rollers, it's a nightmare. So I'm sorry. Let's go ahead and run this and see what happens. So I'm just going to, just like Jupyter Lab, I'm going to say, actually, I'm going to make sure. Hold on a second here. I'm not going to shoot myself in the foot because I don't know if I properly equipped myself. Yeah, sorry. Do a quick little cleanup. In we go. Don't mind the command line. So we're just going to run this, and it's going to run through some basic steps. But to this whole notion of a recipe, what this is doing, if it actually works, is it is going to embarrass me. No, there you go. So it was loading data. This basic recipe, as you can see in the outline, is the idea around, hey, what if I had a recipe that was going to do some basic capability, and it was going all the way from the level of, I didn't have a collection, I didn't even have data in that collection. And I wanted to share a certain search experience or a certain situation in Solr with somebody else. And I'd like to be able to do that without it being like, oh, you're going to have to run this code, get some weird stuff. I wanted to make it something as simple as possible. And that's what these recipes are. These recipes, if we were to look at the file underneath, it's literally just almost what you see with a little bit of magic to separate the cells. Now, the thing that is very different from Jupyter Lab is that a cell can be one of many different languages. So it can be Vespa, it can be Markup, it can be Python, it can be JavaScript, it can be Solr. And each one of these cells, I can go in and literally, see, this is a magic moment where I'm going to embarrass myself. Yeah, we're going to do a query here. I can add a cell, and I can autocomplete. I'm lucky. Oops, I'm not in Markup. I've got to make the cell the right type. But once it knows the right type, it understands how I can, function at that level. So I want to do a select query. it understands that it's dealing with that collection. So as soon as I complete it, it goes to that collection and starts to look at the fields that are there, so I can go after things that are interest. You can even look, as you can see here, it's loading the actual terms. So now I can start to go through the query, and then I get the query. Again, this is not just whimsical feature stuff. Think again about Thomas Edison. Somebody gives me data, I want to be able to work with it quickly, or somebody gives me data, I've discovered something and I want to share it with somebody else. How can I be productive here? So this is not just that I'm running multiple languages, but in each one of those languages, I can be more fast and efficient in that language. And I'm going to step back for a second now. I just want to give you a basic introduction to the notion of a recipe. I have many recipes. If you look at the top left corner there, we've got some other perspectives. Because when you do data science work, you're typically, I find, jumping around between different scenarios. Remember that whole machine learning methodology I laid out? You could see I'm jumping all over the place. I have a lot of different questions and concerns that are coming to mind. So going across the top from right to left, we have a topography. This is more about like, okay, what do I have in Solr? This is almost like your typical Solr admin. You know, I can see my collections, I can see my nodes, I can see how their shards are distributed, I can see my configurations and do things to them, etc. Then I have the recipes. But the other thing I have here is I have the ability to explore, which is not the same as writing recipes. It's more about how quickly I can work with the data. So I can take a query like I've just run here, and I can open it inside the Explorer, which at first looks like it's the same thing, right? It's again, I'm taking the query and just basically the tool is copying it over for me. But this is now getting in the essence of multi-perspective. Because I don't know about you, JSON, you know, there's worse things than JSON, maybe XML to look at, but I personally prefer to look at things where at least, even if I have an undefined a new set of data, at least it's doing type understanding so I can see those data types and it's present in the data, right? That is a really nice thing. And then here's another big thing. If we're dealing with something like anything Lucene-based, I've got a lot of fields. Well, I would really like to be able to not just, I want to know right up front what those fields are. I want to know what those types are. And I want to know what things, you know, about those fields right there. Because what's happened here is, as soon as this gets access to a server and a collection, it's going out and getting the metadata. And then the metadata is part of my experience. I can see not just, you know, top turns, I can see distributions. So now I can very quickly look at a new data set and start to understand what's in there. What am I dealing with? Which is huge. In the work that I do, I have to always, you know, I'm aspiring obviously to get to amazing, you know, functionality and capabilities, but there's fundamental things you still have to know, like what, you know, Unicode blocks am I dealing with in my data set? Because if you're doing machine learning, you may think the dash is the dash. Does anybody know how many dashes are in CCFA? Yeah, exactly. And you can say to yourself, oh, Christopher, you can just map them all across. Oh, yeah, right. And just wait about the lossiness in situations where there is a distinction and it does matter, right? So what I'm not showing you here and what is actually behind part of what's in this whole suite of things that I'm going to be tossing out there is something else which I love, which is called akka. Anybody heard of akka? It's a high-speed streaming library. If you're in the finance industry, you know damn well what it is because it's extremely popular among people in Wall Street who are on the JDK, but they want something extremely reliable and extremely robust. It's been around since the beginning of Scala. It was originally an actor model, got pulled out of Scala, made into its own library suite. As of 2 years ago, it got 2 billion downloads. So it's not something new or novel. It's something so rock solid. The company that supports it, as of last year, I think, boldly came out and said, if you use the licensed version of their Akka product, they will indemnify you against data loss, which is a pretty damn bold statement about the reliability of something. And here's the better part. You can use it in a distributed fashion without even using Kubernetes. So it's a lot easier to manage. Anyway, that's behind this. So what happened when I ran this, I'm using Akka. It went through, my Akka stream is basically a bunch of opportunistic little detectors. And they are all trying to detect all kinds of things, from low-level things like, hey, what's your Unicode? What characters are here? And then it progresses up to more sophisticated things like, oh, look, I'm looking for, you know, types and parts of language, right? So I can see everything like, hey, you know, what proper nouns are in this content? And that's just because there's a little node on the graph in the stream going through Akka that says, hey, you know, I can plug in any language model I want, but I use basic ones typically, but I can build custom ones. And then it's just pulling out those parts of speech. And I can take those and I can look at different phenomenon that's in language, like the nouns, the verbs, the intersection between them. Look at the use of white space. So there's a whole bunch of things we can do. What I'm going to show you here, continuing the Thomas Edison notion of how to work with things, is, I have some favorites at the top here. I've got a heading hierarchy. This data set that we're working with is also something that I'm going to be giving away, or the tooling around it I'll be giving away, is when people come to a new search experience, especially now as we get into vectors, the challenge is around what does it mean to work with semantics, right? And that's the beauty of Wikipedia, obviously, as we in part learned from the LLMs, and that's why they crawl it, because it's got such high quality content embedded by humans. Well, if you're learning about search tooling, or you're trying to learn about how to do natural language processing, I also think, or even just basic search functioning, I think it's a great exemplar to have. And so the crawler I'm going to be tossing out there allows you to slice through a part of Wikipedia that means something to you, right? Instead of it being like, oh, here's all of Wikipedia, which of course would be massive, or here's some toy part that doesn't relate to you. Literally, you can start out with a seed list and it will give you the related content. So in this case, I said, hey, I asked an LLM, which was an interesting experience. I would like 1,000 articles on Wikipedia that relate to data science, machine learning, and search, okay? And the best part was I went to all 4 big languages, the big models out there. None of them can give me 1,000. The best I got out of one of them, which I can't remember if it was Gemini or OpenAI, I got 500. And some of the ones I actually got I thought were really bad, but anyway, I got the 500, and then I found I had to iterate, which became a whole part of this whole research project, how you iterate. But when I parse the content, the other thing that's big, if you talk about how the LLMs work and how they want to do RAG, you run into this problem of chunking. The other thing, the reason I love Wikipedia is because Wikipedia is easy to parse into chunks based on just as you as a human would look at it, because you've got headings, right? So fragments, to me, contextual fragments are typically going to be your paragraph, your list, your table. But if you've got a heading, you've now got a natural decomposition. So here, if we look on the left, you see I've got a heading hierarchy that basically is showing me the headings that are relevant based on the single term I'm looking for. But wait a minute, if we're interested in understanding data as quickly as we can, we want to be able to look at that data in as many different perspectives as quickly as we can. One perspective is certainly a tree map, right? It is not a big deal to take something that's in a hierarchy and put it into a tree map. Different visualizations that are out there are there because they're trying to deal with the fact that, or help humans, because we are much better visually than we are at reading. My ex-wife could always read like 10 times faster than I could. It drove me nuts. But visually, I could completely outdo her because she wasn't very good about, most men are good at spatial orientation, women are not. But the point here is, being able to quickly see things is an important aspect of how we as humans function. The same is true if you're exploring, that you want to see things in a custom format. So if I already understand the structure, then why not see that same content actually as its native orientation? So all it's doing here is now I've got a perspective in the application that I can activate that's just trying to take advantage of what metadata it has available. And in this case, it has metadata that relates to images. Hey, I can render that. So it's actually going over the internet, grabbing those from Wikipedia's site and just making them visible. And I can now start to understand better what's there. It's even at grabbing, this was actually particularly pleased about, I was able to grab the mathematical expressions, right? And not just be stuck with the latex, which is awful to try and read. That's pretty hard on the brain. So, this is helpful. Let's see though, can we go further? If I'm looking at content, I want to understand it. I know there's a query out there that Mr. Pugh loves, which is, I want to look at the significant terms. Okay? So if I'm focused on distribution and I'm dealing with a lot of things related to machine learning, let's see what that looks like. Again, I'm getting a heat map. I've got a heat map which is giving me an appreciation for the terminology that is present based on my, a scoring. So it's not just going for the most popular things, it's giving a higher score to those things that are present but also are unique to my foreground query. And not surprisingly, if you notice this list here, notice I searched for distribution. Do you see distribution there? No. Why? Because in the nature of the content, the distribution here is a generalized term over something else, which is what we see in the list, right? These are different types of distributions that we see. You may not recognize them, but that's what they are. Well, wait a minute, we could actually go back and look at this in context. So now, because we did significant terms, that's more metadata. I can see that in line with what I'm actually looking at. So the point here is, right, back to Thomas Edison, how is it you had so many great innovations? And he purportedly said, it's because I can do as many experiments, it's a function of how many experiments I can do in a day. The reason I built this tool was not because I was trying to build a product or anything else, it's because for my consulting work that I need to be as productive as possible in exploring data. And I needed something that allows me to much more quickly work through that data, discover what's there, what I can get out of it, how I can make it actionable, and give it to the client. Sure, as I said, I'm not a fan of Python, but it's duct tape. And sometimes duct tape is useful to give you a starting point, but then you can turn it into something that's more robust. Now, I'll also mention, as we've been sitting here doing this, we've got some other things that have been happening in the background. It's got a full history. It's keeping track of everything I'm doing. So if you forget what you were doing, you can go back and look at it and see it. Something else it will do, and this is something which we're going to be doing a lot more in future releases, is you can see today, as Eric was saying, why do we have this notion that we look at queries as this weird syntax, right? Well, if I'm a human, right, and I'm, whatever, I'm creating a more and more complex query, why do I have to look at it that way? I could be looking at it as a visualization, because the query itself is actually got metadata, right? I'm defining those terms, and I want to see the counts related to each thing and how it's contributing to my query overall. So again, this is just like, I'm working in a lab, I want a tool that will help me rapidly, quickly discern what's going on, either because I'm starting out or because I'm trying to iterate through my machine learning journey of exploratory data analysis to get to things that I can actually act upon, and I want to see that as quickly as I can. Is there anything else I want to show you at this time? I think we'll leave it there. We're going to go back, in the interest of time, to recipes. So in that first one we did there, we were loading, I just wanted to get this notion of a recipe out there. So you can see on the left, we started out with creating the collection, loading the data, and then just doing some basic things. So we'll now look at a different recipe. I'm not used to working with this resolution. Now we look at something very different. So this is the original use case that I mentioned, where I was like, okay, I wanted to ask, I wanted to get a list of articles for this demo, because I'm also working on this effort to try and have a shared set of Wikipedia data for performance testing around vector search and so forth. So I went out there and got the initial list, and then I was disappointed about it. And so I'm like, well, I want to see how I could get a better list. And so I wrote a recipe to do that. And in particular, the more I work with Wikipedia data, I thought, is there other metadata out there that will help me better understand this data and how popular it is to other people? And of course, Wikipedia being the thing that it is, there's a lot of APIs that allow you to do that. So there's APIs where you can literally go through and crawl and get the views, right? So I can get, views for any different article or a whole series of articles. You can see which ones are popular. You can also go through and even get the historical data, but that's a whole nother thing if you want to get that historical metadata, like how big was this article and how many links were to it, how many links are inbound, how many links are outbound, etc. So let's go ahead and try this again. We're gonna run this, but we're gonna do something a little unusual. We're gonna run only part of this recipe, because then I'm gonna try and talk you through it if I don't end up angering the demo gods. All right. All right, so basically what we did is we ran through and, here we go. We ran through and there's a query I had where I was pulling across the passive query from the data we loaded, all the articles that are there. And then what I did is, in a previous offline moment, because Wikipedia doesn't like you banging on their APIs as fast as I would like, I pulled off all their viewing data, and then I just loaded it in out of a file just to save time for a little demo here. But you can see now that I'm basically, whatever the data thing is, I want to see it as a Cartesian product, which is, not surprisingly, it's a data frame, right? So I can now see a data frame of that data, And again, it's like, okay, this is useful, but wait a minute, I'd like to, be able to better visually understand what's there. So, bear with me. Here we go. So I can say, if I want to, well, I can actually write from people. No, I'm going to do that. If I go off script, I'm going to just hurt myself. So that is that. That is that. Yeah, so let's try this. So I'm working my way down towards a subset. So I crawled and got the Wikipedia API for views only goes back to 2015 because they had to change in the data format. You can go older than that, but it's like you're now jumping between two different data APIs and data formats, and it gets a little crazy. So what we're going to do here is we're just going to display data in the data frame. So I went through and I took all this data on the views and I sorted it for 2025. What are the most popular ones, right? And so as you can see here, web scraping is clearly, rules a day. Everybody wants to web scrape in 2025. Then artificial intelligence, and then Python. Well, has anybody here heard of an Apache tool called Apache Zeppelin? Which I don't know if it's really maybe gone to the attic or defunct, or it's still there and just sort of going along slowly. But one of the things that Zeppelin had that I really loved was this speed to visualization thing. Now, I just showed you speed to visualization when I'm in an Explorer view, but that's just because I'm taking the query directly and showing it to you, and that's kind of what Zeppelin did. What we're doing here is we're putting things into data frames. So even though I can do a Solr query, I can bring it right across into Python for you, and the tool's doing that. So now I don't have to write more code to do that. It just literally brings it across, and then I can get the benefit of not just seeing the data frame, but then I can get the benefit of trying to create a visualization of that is helpful for what I'm doing. And the other thing that again, plagiarizing from Zeppelin that I thought was awesome, it's like, well, I can jump back and forth between different views, right? Different graphics sometimes tell a different story. And that is, to me, the power of the data frame. So here what we're doing in this platform is we're using the data frame as just a conduit to get to a graph and get to visualization of the data. It's not the only thing for it itself, right? It's not the raison d'etre. Moving along, sort of thinking about this whole, back to the Thomas Edison situation. Everybody, I'm sure, understands the notion of a dashboard and looking at data. So in the work that I do, this is the same sort of thing that I'm typically after, because once I've gone through made discoveries and I'm trying to share things with my clients or my colleagues, I have to do that. How am I going to do that? Am I going to put that in a PowerPoint? Am I going to send them data? I could send them a recipe now because I've got a tool that will do that. But ideally, what I really want to do is I want to be able to send them a interactive experience. So I can, let me see if I can do this without breaking things. Here, we're just going to run the rest of this. So what I'm doing here is just going through, creating some visualizations, and then actually putting them in the fourth perspective, which is in this UI, which is the storyboard. So basically, I can be sitting in the data, looking at the data frames, discovering them, charting them if I want to. I can even, from the recipe, be like, hey, put this in a storyboard. So just manually click, boom, push it over. Maybe I create the name of a new storyboard. Or I can, if I'm going to be running through multiple different queries and wanting to see different permutations, I can do it programmatically. And so here, we've got the donut chart, we've got the simple column chart, and then my personal favorite right here. Anybody know Hans Rosling? Ever hear of that? Famous TED Talk, 2013. He was with he was an academic, and he was focused in sociology, I think, and he was looking at the evolution of birth rates and mechanization, longevity. And he did a TED Talk in, I think it's 2000, no, it must have been 2010. It's just amazing. He was the first one to show the animated bubble chart, which is what this is doing. I've now just taken those top 20 topics, crawled to get the intersection of three things: the views, the number of links, which is how connected something is to all the other content, and the number of lines, how big the article is. The size of the dot is the amount of content. And so what's funny and it's sort of fascinating at the same time as you look at this is you would think things just sort of went in one direction, but no, because Wikipedia is a living dictionary. The number of links and the number of lines are just constantly gyrating. in and out. And of course, it's also at the same time showing you how things become popular and trendy and then fade out. And actually, I kind of cheated a little bit and I knocked, what did I knock out of here? I knocked artificial intelligence out of here, because if you include that, it's like everything just gets jammed at the bottom. So I just knocked it out. Anyway, the final thing, which is really awesome about this, is, okay, we're inside the tool right now, and I can save and have a whole bunch of these storyboards inside the tool, and they're interactive, and I can do things with them. But the thing that's really awesome is I can export them. And I can export them and then have them be, I can export them and they become a single standalone HTML page with the data inside, which then you can just attach to an email or zip it and send it to somebody and be like, hey, look what I found. And as you can see here, I mean, it's kind of primitive, but we now also support markup, so you can even, tell the story, describe what you're doing, and it's not just the image. So, as I started the presentation, we're coming up on the end here, the main thing I was doing with this is this idea of how a researcher, because increasingly we're all dealing with just a lot of data, foreign data, different situations where we are in a way all becoming to some degree data scientists. How can we be more productive, but also how can we better collaborate with each other and share that experience? Once upon a time, actually, I think it was the Netscape internet. What was the Netscape tool?
Navigator?
Thank you. The Netscape Navigator team did a promo POC video on what they thought the internet was going to be in 10 years, and it was really kind of inspiring as of ideas, but it wasn't like implementation based, so it was kind of a lot of the hand waving stuff. But it was in this vein where it's like, hey, I'm going to discover things and I want to share it with people. Now, how can I do that? And I'm not going to say that I got there, but that's definitely what this is about, is how can we better collaborate as researchers, as data scientists, as search specialists, and also how can we bring more people into the conversation, people who are not necessarily today programmers. I personally learned best by example, and if I can go look at some recipes, and there's data related to those recipes, and I can see examples, I've got an LLM who can help me understand how to modify it, then I can probably move a little faster. So there you go, there's my talk. Any questions? Go for it.
I saw Vespa in there briefly. How hard was it to integrate that as a backend to your tool?
Actually, pretty easy, because this is really like my 9th or 10th UI I've ever built. So I'm pretty good at making things modular on the back. I apologize to anybody in the Elastic or open source community, but I'm trying to help Solr. The only reason I'm helping Vespa is because not only they're an Apache license, but because a friend of mine went to work for Vespa.
So, yeah, +1. We need more search engines.
Well, the great thing, I don't know if you know Robbie, the Romanian gentleman.
Don't.
He used to work for Semitext, and then he joined Vespa July of last year. And he was helping me do this because he worked and was giving training on Solr, and he was all excited about that. And then he left, and I'm like, oh, dude, what are you doing? You're killing me here. You're destroying. You're my main tester. You're my main feedback. But then I realized, if he goes to Vespa, I've always wanted to do comparability of performance. And so what we're working on is having this exact same wiki data set in Solr and in Vespa in the same tools, literally, giving you the same interaction.
Great.
And it's funny too, because they, one of the first things I discovered, which shocked me, is they have no terms API. And I'm like, what? No terms API? Like as an NLP machine learning person, that is like one of the main value propositions of Solr is having no terms API, among other things. And so in talking to him and talking to his boss, they're actually now going down that path. They're going to add it. So it's like,
Great.
yeah. Any other? Yeah.
So memory usage of the tool's got to be pretty high if you're storing all this stuff.
Yeah, I gotta say,
around.
when you first build it and you got the idea, and then you realize the memory constraints in reality, especially when you're trying to do visualizations, right? The library we're using for most, not all visualizations, is eCharts, and eChart has a sampling construct, so you can render them and sample them. What you see in front of you right here, which looks like a chart, is actually an image, which is a cheat on that very issue on memory, right?
Yeah, but even when you ran the recipes that you were talking about, you were able to click on each cell and it actually had the data behind the scenes. Like,
Yeah.
That's
Well, so what, and that's another thing, it has to do with productivity, right? The whole research cycle is, I find, really discovering data, you will have times where you really want to be able to step in and see that, and then you've got to be a good boy and, you know, turn off like visualizing it because you're just eating up memory.
But you're running an Alienware laptop that's huge, right? You got 32 gigs. I mean, right? That thing's got 32 gigs.
64.
Yeah. So, like, not a problem.
Yeah, I mean, yes, this is the you know, first you go after the inspiration and then you try and make it perform. And but the great thing is, you know, the whole, my first UI for Solr was in Flash. Everybody remember Flash?
Oh, yeah.
Okay, yeah, like, because there was nothing else. There was nothing even close. Steve Jobs came along. At the time it pissed me off, but in hindsight it was a good move. He killed it because he refused to put it into Safari, right? And then what happened? Well, it took a while, but then all the stuff moved over to JavaScript. So JavaScript has got a very rich ecosystem of visualizations. And, funny enough, guess what happened to Flash? Flash got ported to JavaScript. It's called 3JS. And we are in the process of bringing 3JS in here because we've got a 3D rendering. I'll show you this. This is pretty hackish. Another popular query in Solr is semantic graph, right? So you're looking for latent variables inside the data, and you want to be able to quickly find them. The noun phrase, and then go again. So basically, I've got a separate. So you know how you read a Wikipedia article and you see all those like links that are to something else. So I broke them out into separate fields. So you have the articles, and then in each side of the fragment, you have the reference to each of those, what I call linked entities. I really probably should have called it linked articles. And so this is just going to fire the semantic graph query, and then bam, you get the interaction, and it's taking the scores as the thickness of the lines, right?
Oh, cool.
Right, and so now again, it's the same thing. But here's the funny thing: as a data scientist, this may look great to you, but this to me is horrible. Because why? I want to make it bigger. And if you're in 2D and you're trying to make it bigger, you just have to get bigger and bigger. But if you go to 3D, all of a sudden you can make it that you can go around things and you can compress more. So I've actually got in a different library called Faerun, I've got up to a 400,000 node version of this.
So you're saying next year I don't need to bring my Oculus Rift glasses to watch your demo? Is that going to be prerequisite?
Really put 3JS in.
So this all looks really cool. Where do I find it?
So it's out there on the web. If you're feeling
You have a
bold and you want to download it, you just Google search for Solr Navigator, and it's under, I think it's under searchnavigator.org. And so there's a website, just downloads. It's out there for Mac, Linux, Ubuntu, and Windows.
Cool.
So, and as you're going to see on the site, we aspire to have a beta release someday. This is still very much out there. It's kind of fun because I'm using it on multiple client engagements. And in fact, I've even given presentations to clients of their issues in the tool. They don't even know what it is. I don't tell them what it is. It facilitates the conversation. They love it. They're like, hey, great progress, Christopher. You know, give me a round of applause. And I'm like, thank God they didn't ask to use it. But I'm really doing it. Part of the other reason this has been fun is I've got a client that I just got last year who is interested in doing very complicated quantitative mathematical functions against telemetry data. And I've never done that before. So it took me back to school, looking at a bunch of stuff. And then, I'm like, oh my God, I've got to implement these somehow because there's no library I can pull down. Anybody here of Polars? Anybody know what Polars is? Oh boy. So you know what Pandas is for Python. Apparently during COVID, the gentleman who I think is somewhere, maybe Swedish, Scandinavian gentleman who was learning Rust, thought, oh, we need a data frame in Rust. So I'm going to go write one. And not only did he want to write sort of the equivalent to Pandas, he wanted to, in my opinion, I'm very grateful for this, sort of improve the APIs to make them far more intuitive than they are in Pandas, because Pandas is pretty convoluted if you're trying to do things very powerful, very capable, but also like, whoa, I don't know what's going on. So he's kind of an API Nazi. His APIs are just beautiful. And the thing is, I started using it. It's extremely fast. That's what we're using inside of here. Is we're not using pandas. I mean, you can if you want to, but we're using polars for the intersection between the visual solutions. It's very powerful. They've got, with polars, he's got streaming, not streaming expressions, but he has expressions. So you can write very complex mathematical expressions, and it will do it for you. And you can, and the beautiful thing is, I've got some of these really long, chains of mathematical functions, and I just look at it and it's easy to read. It's like, I understand exactly what's going on here, and it's highly performant. It's like, who knew there was such a thing, right? So that has been a lot of fun. That has been a lot of fun. And it's not just like, oh, give me min max. It's things like, give me slope, or, give me, the different statistical, skews you're looking for, variance and stuff like that. And it's all doing it inside the data frame and very easy to pull out, which is just awesome.
Just to advocate it, Polars is based on Arrow
Yes.
for
Yeah.
memory management of data. So anybody just want to communicate in arrows?
Just saw a talk earlier about this.
Yeah, it is fun stuff. I have really enjoyed learning Polars. I hope it spreads. All right. Well, thank you for coming. Late.
Thank you.